All right, folks, I think we've pretty much leveled off, so we're going to get this show started. Thanks for joining us. I'm Travis Durick with PepLink. I'm a product manager here at PepLink, and we've got two guests today with us to talk about LoRaWAN. We're going to talk a little bit about LoRaWAN in general, and then we'll talk about the PepLink solution for LoRaWAN. And so we've got our two guests today. We've got David Smith from Get Wireless. He's the VP of IoT Solutions. He's got long history in the IoT world and specifically also in LoRaWAN. So very happy to have Dave with us today. And we've also got Mike Anderson from Get Wireless. He is the Senior Director of Product Management for the PepLink product line at Get Wireless. He doesn't like that senior word, but I threw it in there.
That's funny. Thanks. We just talked about that and you threw it in anyway. Awesome.
I had to do it. I'm sorry.
That's great.
So yeah, we've got a good panel here today. And like I said, we're going to dive in and talk to you about LoRaWAN technology overall and what the PepLink solution for LoRaWAN looks like.
Yeah. So thanks, Travis. And I figured, kind of put a little bit of agenda together for this session. The first thing I thought we'd talk about is the architecture, right? What does it entail? What do you need to get LoRaWAN up and running? And then talk about some LoRaWAN examples that are out there and all the different things that you can do with it. I have a couple of things set up today and maybe show you some stuff. And then talk about what makes PepLink different with LoRaWAN, why PepLink, right? And then get into a demo and then open it up for Q&A and see what people are asking out there. So I hope that's a good agenda. We okay with that? Anything else we want to add?
I think it's great, but as always, folks, feel free to chime in on the chat. We'll probably take most of those questions at the end, but don't be afraid to throw them in there now, and we'll be happy to talk about those as we get to the end.
I'm a little new to Zoom, so I don't know where the chat is, but that's okay. I'll find it. All right.
I'll manage that stuff for you. No worries.
Okay, thanks. I'm like, I don't see a chat. All right. So let's kind of talk about the LoRaWAN architecture. It is a little bit different, but it's pretty simple. So this is where Dave and I can, kind of interject. But the first thing you need is that application server. You need something that to communicate with that LoRaWAN. Then you need the network server, and then where PepLink will fall in is in the gateways side of it. And then that's got to communicate with the base station. And then you get all the sensors. So to me, the way this is set up, it seems a little bit, right to left. And I think I normally go left to right. So it's a little bit different because when you deal with LoRa type stuff, the sensors are the most, the thing that's out there, that's the most visible thing. So I have a handful of sensors here. I have a motion sensor or a vibration sensor. I have a temperature sensor, and then I have a push button sensor. And, again, that's going to talk to I have it connected to my Balance 20X. And in the 20X, I have that LoRa WAN module plugged into the back. So that's how the sensors are talking to the gateway. And then from there, it's going to go to an application server. Dave, I don't know if you want to talk about anything in network architecture wise. I just kind of quickly went over it.
Happy to. The whole basis for LoRaWAN is considered like a hub and spoke. So you have an end device, a sensor, and it's going to go generally through a gateway and then having its traffic sent up to the cloud. And then the network server, that big cloud thing there, is generally in the cloud, doesn't have to be. And there are applications where it's not, but generally it's in the cloud. And that is the opposite end of the communication channel. The other end is the sensor. So if you think of like two tin cans and a string, one tin can is the sensor, the other tin can is the network server. The gateway kind of sits in between and is kind of like the string, right? Once you've set that up, you get a lot of really good benefits. One of the benefits with LoRaWAN is that all of the data is encrypted from the sensor until it gets to the application. And that's very important for a lot of different applications, right? But beyond that, the network level traffic is encrypted separately from your application level traffic. So that means that whoever is carrying your LoRa packets from your sensor, that network cannot see what the payload is from those sensors that is not decrypted all the way until it gets to the application side. So the great thing about that is you can rest assured that this is a completely secure architecture from end to end, which is very important in many things today.
So
Awesome.
just to kind of zoom out here, I think a lot of folks on the call probably understand this, but the LoRa sensors are a wireless technology, right? It's a long range. That's LoRa, long range. And so you've got much longer reach. It's similar to Wi-Fi in that it's, decoupled from that device. There's no Ethernet cables, but much longer range, right? Than we're talking about with anybody who's used to Wi-Fi.
Yeah, LoRa was the unfortunate result of letting engineers name a technology. So LO for long, RA for range. I don't know if a girlfriend was involved or not. But you're right. It uses sub-gigahertz radio technology. It's wireless. That sub-gigahertz radio technology, just in general, is got awesome propagation characteristics, right? It can go really far. It can generally penetrate deeply into buildings and other structures and things like that. But built on top of that is the LoRa modulation. And then built on top of that is the LoRaWAN protocol. So that stack of technologies gives you a signal that goes really far or penetrates deep into buildings, so basements and things like that, car park structures, they still get good signal, and you get it done reliably, which is one of the key things with IoT, right? You don't want to lose contact with end devices ever, if at all. So that's part of the nice part of LoRaWAN. It's a stack up of technologies from the radio frequency to the LoRa hardware to the LoRaWAN spec. It all creates a very good, strong communication channel.
It seems like, I think there's been similar technologies in the past that have even used those same frequencies, but I think what you're saying here, it sounds like, is this is really an evolved version or an evolved spin on that, and there's more to it than just that radio link. There's a lot more behind this technology than maybe previous attempts had.
Well, it's based on chirp spread spectrum, and chirp spread spectrum was actually developed near the end of World War II with radar. So if you imagine, if you're trying to make radar and you want to be able to see something very far away, right? And reliably bounce a signal off it and then be able to understand that signal when you receive it. A lot of those requirements are very similar to what we have today with IoT and LPWAN. And that's where chirp spread spectrum was originally developed. Now, the version we have today is better, definitely. But this is technology that has been around and proven for a long time.
Very cool.
Yeah, just to give you an idea, I was messing around with some of the sensors here that I have, and I drove around. I went about a little over a half mile away from this, and I was still able to get some reads. I've seen in some cases where you've gone over a mile and you can still get some information off the sensors. Some of the local or the co-ops, the electrical co-ops, they use LoRa, and what they can do is, instead of sending somebody out to manually read a meter, they can jump from 1 meter to another meter, and it could be miles away, and still get that read off of it, so they can save time on that. So again, just to give you an idea of the distance, the long range that you can get, it can be pretty far.
Very cool.
Okay. I think that pretty much wraps up the architecture. I did see a question that we had on the chat. I did find the chat button, by the way. And that was around, the list of devices that are LoRa capable from Peplink. Right now it's on the Balance 20X, and there's a special Flex Module Mini for LoRa. So currently that's the only one that's available. There are going to be some others coming out. There'll be an outdoor version and maybe a smaller version as well. Later on in the presentation, I think we'll show you some of those and give you a list of that kind of stuff. So, but I just kind of wanted to answer that question because I saw it. All right. I think this is a good time to switch over and talk a little bit about some of the examples with that. So there we go. All right. So here's just, a kind of Some of them, I mean, there's a lot more you can get into, you can get into oil and gas, things like that as well. But, these seem to be the more popular. Some of the, I think we can go around and talk, each of us come up with some of them. But for me, smart cities, I already talked about the electrical co-op companies. Those, they utilize stuff like that because they got to go a long ways from neighborhood to neighborhood or meter to meter in some cases. But here in Minneapolis, Minnesota, Mall of America, right? So they have a parking ramp. They have 2 really big parking ramps on each side of the mall. And when you drive in there, there's all sorts of little sensors and stuff. So you can go online, you can see the parking, you can see what's available, what's not available in that status. And when you're driving in there, you can actually get a little light too to say, oh, I can look down the row. If it's all red, I know there's no parking. But if there's green, that means some spaces are available. So that's one big one. The other one is light monitoring, right? So you can get access to, hey, this light turned on, this light turned off, or you can do some control with it too. So in smart cities, you can change it from one color to another color. So ideally, I see stuff like on college campuses or in major metro areas, you can turn a light from red to green, like the street lights, and then you can guide traffic out a certain route. So that's another example of some of the LoRa ones. I don't know, Dave, if you have any.
Oh, wow. Yeah. I have tons. So LoRa is used a lot in utility metering. So water meters, gas meters, electric meters. In fact, I live in Apple Valley, Minnesota, and Apple Valley uses LoRa to be able to read any meter at any time in the entire city. So they never have to drive around and, read meters or, do any of that. They just get it naturally reported. The great thing is that once you have something like that in place, and this is very typical of a LoRaWAN use, is that you get some additional capabilities. So since you can read a water meter, say on demand or have it report periodically, you can now start doing things like leak detection, right? You can do perhaps some load balancing on the electrical side. So there are a lot of things that LoRaWAN gives you above and beyond just the raw data of what's that meter reading. Another example is smart waste. We've done a lot of work with that. Smart waste applications generally have a sensor in a bin. And you could be checking for the bin to be full, or maybe you're concerned that it's going to be empty and you need to refill it, right? And that kind of data is moderately interesting. It's empty, full, right? But when you couple that with other data, you can create a platform, and there are several out there now, that will just simply tell a waste management department at a municipality, say, take those people, that truck on that route on that day, and you're done. And it greatly improves the efficiency and the capability while simultaneously reducing the cost. And if all that isn't good enough, the biggest benefit actually is the carbon footprint reduction. That's generally what the mayors of the cities are really most concerned about, because if you can reduce driving these large trucks by 50%, which is pretty typical of these systems, you're saving a lot of carbon, right? So there's those kinds of applications. For the smart building, there's basically 2 kind of sets, right? There's the building mechanics, like the air conditioning and the air filtering and heating and things like that, that you get a lot of benefits for. You can do, again, leak detection and all sorts of other stuff. But then on the people side of buildings, they're starting to realize that air quality really matters to worker productivity and health, right? Occupancy, how a building is being used by people. There's that whole side of smart building stuff. And we work with large companies that have buildings all over the world. And one of the nice things about LoRaWAN is they can use it all over the world. And they don't have to worry about too much about local regulations and things like that. It just kind of works. Does that all make sense?
Yeah, that's awesome.
Yes.
And the last example I'll bring up is kind of a fun one. So Dave and I, we both live in pretty much Minneapolis, Minnesota, right in the heart of Minnesota. And at Get Wireless, we host a fun event at the end of the year. We host a ice fishing extravaganza, we call it. And we have a bunch of ice houses out on the lake. And a lot of times people come to it and they're like, well, how cold is it out there? What's it like? So what we've done is we've put some temperature sensors in the ice houses so you can see what the temperature is out there. And we run a contest that whoever catches the first, the biggest, the last, whatever the, the type of thing on the fish, you can push a little button, kind of like a panic button, but this is more of a fun way to do it, that you get a fish. So then we could have somebody go out there and they can measure the fish and they can do the judging and all that kind of stuff. And then on top of that, we have another place off the lake for the people that want kind of a little nervous walking on a big frozen lake. Well, we have another facility that's on shore where you can actually see all the information. You can get the latest updates. You can, kind of go, oh, look, somebody caught another fish in Ice House 5 kind of a thing. So it was a fun way to do, to get the LoRa WAN technology out there and utilize it. So that's the other example. And if you haven't been to our Get Wireless ice fishing event, I recommend it. It's a lot of fun. I think all three of us have been there past couple of years. So anyway.
Yeah, actually, and we also had video from outside. We had outside temperature. People didn't like to look at the value it was reporting, but and so we were combining a bunch of different data streams too, right? So we were combining LoRaWAN data streams, but also video. And the nice thing about the Balance 20X is it integrated all those together and reported them back up to the cloud with no problems whatsoever. One other thing I'll mention is in the smart healthcare, there's a lot of work being done on the LoRaWAN side. And it's funny that you had concussion monitoring on there. We actually had a demo with a football helmet on a mannequin and had people hit it with a plastic bat to measure impact. That has actually been around for a while now. And so different sensors on the body are starting to become much more prevalent in professional sports, getting that in kind of real time.
Yeah, not only can it do, that kind of like the hit impact, but it can also measure body temperature, right? Because in certain cases, like right now, in the NFL, they got their preseason or their pre-practice stuff going on where, if they get overheated, because here in Minneapolis, it's 90 degrees out today, and that could be if you don't have enough water or whatever. But you can also, fun stuff is you can detect speed, how fast the person is running during a specific game. And that's something that some of these sports are tracking as well. It's all using the same technology.
That's cool. It reminds me of another one that I've seen that's kind of my favorite so far. And it's not on the healthcare side, but on the agriculture side. I've seen customers reaching out because they're doing this for livestock, for animals. And so whether it be cows or chicken coops, there's lots of different use cases where they're trying to do similar things to what you just talked about, where they're tracking the vital signs of the animals, trying to figure out where they are they where they're supposed to be, and just make sure that everything's moving smoothly and they're able to intervene if there is an animal that needs assistance or needs something to be
that I'm so glad you brought that up, because I know that cattle tracking is, believe it or not, a big LoRaWAN application. And one of the kind of not unique really, but it's one of the special things about LoRaWAN is that you can track the location of an end device, say a sensor, without using GPS. From the LoRaWAN signal that is received by one or more gateways, they can triangulate back and with reasonable accuracy, 20 meters, know where that device is. And so LoRaWAN sensors are used not only to track the health, but the location of cattle in a number of places around the world. One question people may have is, okay, so there's LoRaWAN, and then there's the cellular technologies, LTE-M and NB-IoT, right? Aren't they all the same? And the answer is kind of. They're all LPWAN technologies. The differences between LoRaWAN and, say, LTE-M are mostly superficial, I guess. LoRaWAN will travel farther, has greater distance and penetration than, say, LTE-M. LTE-M has a higher bit rate. So on the LoRaWAN side, you're going to get something from 5 to 25 kilobits per second of data throughput, right? That sounds really low, right? But if you're sending just 10 or 20 bytes, it's pretty fast. On the LTE-M side, what are you going to get? 1 to 3 megabits per second, right? So you're going to get a much greater data rate on LTE-M, but for that, you're going to get a much shorter battery life. One of the things we haven't mentioned up until now is that LoRaWAN devices are often targeted to go for 5 and 10 years off a single battery. That's very difficult for cellular devices today. I'm sure they'll get there eventually, not worried about that. But today, in terms of battery life, LoRaWAN does tend to last longer as well. So those are some compare and contrast between LoRaWAN and, say, cellular technologies.
Awesome. Yeah, thanks. All right. Perfect. So I've seen a couple of questions come in. I think this is a good time to transition over to the device side of it. So currently, I stated this earlier, so this is the Balance 20X. That device has been out for a while now. I think a little over a year, maybe 2 years. I can't remember quite when the 20X came out, but the module is what does the LoRaWAN connection. So as you can see there, it's just the Flex Mini module plugs into the back of the device. It does come with the antenna. Obviously, you don't need power because it gets power off the Balance 20X. And this is kind of a unique setup for LoRa. Not only can I manage my LoRa network, but I can also use this as well for backup primary internet or in an office location. So Dave talks about this all the time, where it brings IT into the LoRa bubble, basically, and you can have both in one device, and that's really unique for LoRa. Typically, your LoRa gateway, and we have a slide on this as well, it's designed just for LoRa stuff. Well, with Peplink, I get both. I have two systems into one box. And the best part is I can use InControl 2 to set everything up, right? I can go into that, I can, do my configuration, and then I can go into my LoRa platform and configure that Balance 20X into that. So I'll show you how simple that is in the demo side of it. I think it's great that we can have this. Now, again, this is the first device they are working on. Peplink is working on an outdoor device, which will, I'm not sure what the ETA is on that. And then they're also working on a smaller device as well, a little bit bigger than the VR1 Mini, maybe more of a UBR, old UBR style LTE that was out there. Dave, I don't know if you have anything else to add on the Peplink side of it, or a typical setup for LoRaWAN.
Yeah, absolutely. So, there are a number of different kinds of LoRaWAN gateways out there, of different sizes, different capabilities. But one thing that's been pretty consistent is that they are generally LoRaWAN only gateways, and some of them use an Ethernet backhaul, some of them use a cellular backhaul. But that cellular connection from other kinds of gateways is, it's there and it works, right? But it's not as reliable as it could be sometimes, right? You have to do a lot of additional effort on the user's part to ensure that the gateway doesn't drop on and off the network. Whereas with the Peplink device, that whole IT backend side of the super reliable backhaul connection over the cellular or Ethernet or bonding them together, that's all there for you. So your IT department can just take this box, they already know how to use it and configure it, and suddenly you now can offer LoRa as well as Wi-Fi in your IT networks. So the key part between the Peplink gateway and, say, other gateways is that ultra reliability capability of the backhaul connection, which is often the Achilles heel in other LoRaWAN deployments.
Yeah, I think that's a huge point, Dave, because all of this is an end-to-end connection, right? You've got to get from the sensor all the way to that application server somewhere else. And this is all only as good as the weakest link in the chain, right? So the LoRaWAN is really long range, really reliable, and that's great, but cellular is still cellular, right? And it's not like it doesn't work, but it's not as easy as people think it is sometimes. And anybody who's deployed hundreds or thousands of cellular devices can understand what the day-to-day operations that look like. And that's really where we value add here, is that we've been doing that for years. That stuff's airtight. And then we've got the SpeedFusion technology to add that reliability. So if you've got things like Starlink or other connection types in play, it all works. It's already been proven. It's all right there to be used. I think the other thing that's really big is all of these devices have eSIM capability. And so, you said there's global companies doing this. Well, how do I get a SIM card for 15 different countries? Well, Peplink's got one built in, right? It's built in right in the product. You don't have to put a SIM card in it even. You just put some antennas on it and you can activate that eSIM right over the air. And so you don't have to use that built-in connectivity. But again, when you're trying to stand this up globally, there's a lot of barriers that suddenly show up, and trying to negotiate contracts in 5, 10, 15 different countries with cell carriers, that's not a quick process. And so there's a lot of things that we really make a lot easier that maybe aren't obvious or upfront to somebody who hasn't really tried to do this at scale yet. But these are all stumbling points that people run into, technical and non-technical.
Yes, and in addition to that, the Peplink platform allows you greater internal operational efficiencies. In many LoRaWAN network deployments, those are done separately from IT. You have an OT, an operational technology team, right? And they're running this network. Are they really skilled at it? Is this their expertise? It may be or maybe not. Most often it's not, because there's ongoing management and efficiency gains to be made well after the networks are deployed. That's just an ongoing effort. And so what you really want is to have your IT staff who can manage and maintain your network for you, so you don't have to worry about that. You don't have to have a separate staff that's going to be running back and forth with IT, asking them about their Ethernet connection or their cellular connection. So one of the great things about the way Peplink did this is to fully integrate this into your IT solution house, so that you don't need the extra staff, you don't need the extra steps in deployment, and it's more reliable as a result.
Awesome. Yeah, I think I think at this point, I don't know how you guys feel about it, but I can get into a demo. I mean, we've been chatting a little bit about, for this whole setup for the past 30 minutes now. If you want, I can definitely jump into the demo. I do see we have a bunch of questions coming in, so maybe the demo will help answer some of those, but we can take those afterwards as well. All right.
I think great. Let's see it.
Perfect. Okay, so I'm going to bring this over. Here's my In Control 2 account. And you can see I have this Balance 20X here with LoRa. I'm just going to click on it, right? And in here, once I show all, you can see the Flex module that's plugged in. You can see how I'm connected. This isn't connected via cellular, it's just wireline. But you can see all the information. I'm going to remote into the device and go to the dashboard. Once I get into here, this is where I can start enabling some of the stuff. So the LoRa side is under the Advanced tab. And then I got my LoRaWAN configuration. So it's a pretty simple setup, right? The first thing is I would just enable it, and this opens up all the controls out here. And then I can select my protocol, whether it's packet forwarder, UDP packet forwarder, or basic station. In this example, I'm using the packet forwarder. And then I can choose my frequency plan. Peplink sets it up for band 1 or for band 2, but in this case, I'm using band 1. And if I know that, I can easily switch it between the different bands. So this is 8 different bands. And then I have my server that I'm going to connect to, and then the port that I'm going to need. The other thing that's really important is this network mode, right? So is it going to be a private network mode or public? And again, in this example, I'm using public network mode. This EUI is important because this is what talks to the sensors or talks to my application server. So this is something that you definitely need to know, because I'll plug this into the system that we're using. And in this example, I'm using the platform from Radio Bridge, and I have a dashboard right here. And as you can see, I have a Peplink demo. So currently I have a couple of sensors set up. I'm actually going to set up a whole nother sensor for us today. But you can see that I hooked up a temperature one. So you can see roughly about, this is about 72 degrees. It ranges anywhere from, this was overnight. So anywhere from about 68, 65 up to about 72 degrees. And you can see the humidity. I went outside yesterday with it, so you can see the humidity and the temperature increase and the humidity change. Actually, here's a big one right here where it got really humid. But good information on this. And then down below, this little graph right here, this is like a door. So if a door opens, it's actually an accelerometer. So if the door moves, you can see that. So you can see that it's been, I've had 20 instances where the door opened. And really what I do is I just kind of shake the accelerometer just to simulate a door. So that's kind of the dashboard side of it. When I come into the gateway, you can see I have this balance 20X right here. Again, so here's that EUI information that I needed to put it in there. I got to tell it a zone that I'm in and the kind of bridge that I'm using. So again, I'm using ChirpStack, but I'm using Radio Bridge for this scenario. And then, is it active or not? Going back in there. So once I got my device configured, I can come back to this and I can go to the status side of it. Under the event log, I can actually get all my information. So I can see that it started connecting and then it actually connected. So this is more of a confirmation thing that I get when I'm actually setting up my device for the first time. And then you can see I also get some alerts in here as well. All right, so back to this. So now that I have my device set up, it's actually going into the sensors. So this is kind of I'll do this one for you. So I can configure the device. I can give it kind of a protocol, or how I want it to configure, like how I want to be notified of stuff if I want to get, information or a message in here. So to give you an example, I can take this. See, I just picked up this door sensor and I can see that it went off already. That little flash of yellow said it started. I can do it again. You can see I get another started indicator from here. Pretty neat information. You can see the gateway that I'm configured. So here's that EUI information again. You can see the hardware, some battery voltage, and then the last scene. So this is some good information that's on there. If I go back to the devices, here's my temperature and humidity one. This is kind of a weird test, but I'll show you anyway. So I have it set up right now that if I want a notification, if it gets warmer than a certain amount, to let me know. So if I go blow on it, you'll see I'll get a couple of alerts just that it's getting warmer. There we go. Now it's up to 24.5 degrees Celsius. So kind of some neat information. And again, if I go back to the dashboard, I can create a separate Peplink dashboard in there. And I can see that information over here on the right that it's getting a little warmer. So you can see the timestamp and all that information. So that's just kind of the basic setup and how you can see some of the information on one of the platforms that's out there. But let's set up a device currently. So what I'm going to do is I'm going to add a device. I'm going to pick the network again. So here I'm using ChirpStack. I'm actually going to use the certain information off this. So I'm going to call this Peplink button. This is my device information. The key, this app key, it's interesting. It's not quite as long as a Peplink license, but it's very similar.
Yeah, so while he's doing that, I'll explain. I talked about how things were encrypted from end to end, right? From the sensor all the way to the application. So a sensor has two key and critical pieces of information. It's universally unique identifier. It's called a DEV-UI. And then it has a root key. And from the root key, a whole bunch of different session keys are derived. For those of you who understand computer security, a bunch of session keys are derived and used for different, very specific purposes. And one of them is to encrypt the payload and to encrypt network traffic and things like that. So that's why he has to enter in that information, because the DEV is a unique number. The key is not necessarily unique, but it's a secret. So those two are key and critical to knowing what a device is and how it works.
Awesome. Okay. So this is the information. The only other one was the select the region. So this is the US. So I got EU and the US region. So I'm just going to use that, obviously, because I'm in the US. But once I got this in here, I can hit continue. I'm getting get a little confirmation page up here. Maybe. Love live demos. All right, hang on.
Wow, I've never seen that.
I know. I wonder if it's because I just removed the device yesterday. Let me see what happens when I refresh the page. Did it go in there? Nope. I'll have to do it all over again. Sorry for the duplication. It's a good thing I don't have to do each character individually. There we go. Oh, that was weird. So I get my confirmation page, make sure everything looks right. Once I confirm it, I can view the device. And then over here is where I can set up a configuration. So this was the last one I used. I'm just going to copy it. That's why it's up here, is that I could change it. So I can have a little light, enable the button press, or I can enable it when it was released. For example, if I had to hold it for a certain amount of time, I could do that, get notification on that as well. But once I set up my configuration, the ones I want, I hit submit. And down here on this setup, I can actually see when the configuration was sent. And then you can also get an alert back when it was received. So it might take a second or two for it to be received. But again, I'll get a little message indication up here of the status. There we go. So there's my, there's a first button push. So every time I get a button push, you can kind of see that. So keep pushing it. So it's pretty simple to add kind of the sensors. And then if I go back to my dashboard, and again, you can see all the information. I can see battery voltage. I can't see that yet, but you can see the button pushes are coming in from my dashboard. You can see there might be another one. I might have to add the screen, but I could add the button push in here if I really wanted to, up on top. So anyway, I can add it right from here, do my line chart, select my device. So you can see all the different buttons that I've had. So yesterday we had 26 times, and today so far we got the 3 times. But again, kind of a graphical information on the information that you have, whether it's a button push, door open, door close, or even a temperature side of it.
Hey, Mike,
So
were you going to show the notifications part?
Yeah, let's see. Did I get any text? So far I haven't gotten any. I don't know if the notifications turned off. Let me make sure that was turned on. Peplink demo, temp demo, button demo. So this was turned off when I deleted the device, but really what I'm doing right here is I am getting a text or an email every time the button is pushed. So this is what we utilized in that ice house or ice fishing demonstration. So when the button was pushed and it went off, we got a text message to whoever. Let's see if I can get one to come in real quick. We'll do a couple. Go back into the demo. There's a couple. Oh, so here we go. I'll try to do this pretty good, but you can see I'm getting a bunch of text messages already, and I'm also getting some emails coming in. So this is a good way to flood my email. But yeah, you can get information that it tells you. The nice thing is it tells you the information like the RSSI. So if I was traveling far away, I can see how weak of a signal I'm getting. So I know I'm on the edge of that reception point kind of a thing. So yeah. But you can, yeah, again, notifications are really simple. I can create a new one. I can add it, the notification name, the type. It's going to be a single device type, obviously. And then I pick the button I want, and then I have certain triggers and rules. And again, each system, so this is how Radio Bridge works, but all sorts of other applications might have different setups. But just to give you an idea on how to configure it, it's pretty simple. And in some cases, it's easy to configure. But anyway, that was the demo. Perfect. All right, so I see we have about 15 questions. Travis, do you want to start asking some of those? See which ones we don't have?
I think the first one's an interesting one, but I don't know that we have an official answer yet. Will the LoRaWAN Flex module be Amazon Sidewalk compliant in the future? Making use of the Sidewalk network for extended range. You know, I know we've definitely been looking at projects like that. Dave, I don't know, you know, I can't officially say yes or no, it will or won't be, but it's definitely an intriguing one. Dave, what do you know about
I can talk to that. You know, Peplink is a member of the LoRa Alliance. Get Wireless is a member of the LoRa Alliance. In fact, I'm one of the original authors of the LoRaWAN spec, and I currently am chairperson of the certification committee. And so I can tell you that within the Alliance, we are working to harmonize LoRaWAN with Sidewalk. And so probably not until perhaps early 2024, because it's being worked on now. There will be some way to have devices that speak LoRaWAN and Sidewalk kind of interoperate. So that's definitely coming. It will probably be a very, very simple thing to support. So I don't doubt that in the future, if I came to Peplink and said, you need to make this slight tweak, and now you can talk Sidewalk, that they wouldn't do that. But I can't commit for you, Travis, right? But the Alliance is working on harmonizing these things, and eventually it'll be part of the standard spec.
That's awesome. Yeah, I mean, I think that pretty much answers the question, but again, we got to see it actually take shape to commit on that. But yeah, if the industry is moving that way, it's highly unlikely we would not. Cool. So we've got that one. How do you mitigate bandwidth issues since LoRa is using unlicensed frequencies? So I'm guessing they're talking about like congestion, things like that.
Oh, sure. Okay, so I'll try not to make it too complicated, but you'll have my email, and I am happy to go as deep as you want on the technology side. But basically, the way the signal is modulated, you can actually have up to 5 or 6 devices at the exact same time, at the exact same frequency, all talking simultaneously, and receive all 5 or 6 of those things. And that's because there's a thing called a spreading factor that goes into the modulation of the signal. And so you have spreading factors that I think some of the Semtech devices go down as low as 5, and it goes up to 12. Now, in the United States, we can't go to 12. We stop, but I think at around 10, and that's due to FCC regulations regarding time on air. But what these spreading factors do is allow you to, spreading factor 7, 8, 9, 10, you can send a signal on the same frequency at the same time, and they will not interfere with each other. It's kind of like if you've ever seen a prism, right? And you hold a prism up and, you know, you're surrounded by light. And when you use the prism, you see it breaks it into blue, green, red, orange light. And the light is all existing in the same spot at the same time and not interfering with each other, right? Well, it's similar concept with LoRa that way, if I could put it like that.
Which
So
is
because of
different
that,
than
you can get
Wi-Fi.
great device densities. So you don't generally have to worry about that.
Sure, and that's very different than how, say, Wi-Fi operates as a protocol.
Oh,
right?
yeah.
Wi-Fi does not allow that same kind of feature or capability, but
Yes, Wi-Fi, you know, you're sharing, right? It's my turn, it's your turn, it's my turn, it's your turn. Whereas with LoRa, you all just talk at the same time. In fact, very briefly, a LoRa endpoint has 3 different ways to operate class A, B, and C. And it has nothing to do with the alphabet. A stands for all, it's base functionality. All LoRaWAN devices need to implement that. And that is basically a device sleeps, and whenever it decides to wake up, it talks. It doesn't do CSMA CD, it just wakes up and it talks, and the gateways will hear it. Class B is with a beacon that gives you reduced latency from the network on a beacon period basis, so that a device can wake up periodically to see if the network wants to talk to it. And then the class C is continuously listening to be talked to by the network. Each one has different power profiles. Most devices are class A, but that we base the whole operation of class A devices on the fact that there really aren't any issues with getting onto the spectrum from other devices in the United States.
very cool. Another question here, would LoRaWAN or BLE be better for tracking specific location over a large area? And I'm gonna throw this back to you, Dave, because I can't compare the two technologies with intelligence, so.
Sure. So first of all, Get Wireless is device agnostic, right? We do a lot of stuff with LoRaWAN. We do a lot of stuff with cellular and Bluetooth and NFC and a lot of others, Wi-Fi. It depends. Generally, if you're going to track over a wide area, so an example is in South Africa, they do cattle tracking. And so they have set up gateways that kind of surround an area within which they're going to have cattle roaming around. And this area is miles on a side. It's a very large area. Well, in that kind of situation with a little tag on the ear of the cow, LoRa would be best for that, right? And for that, you're going to get, 20 meter, 17 meter accuracy, which for a cow is pretty good, right? I mean, cows are large. If you're within 17 meters, you can probably see the cow. Now, if you're talking about a very large warehouse, right, and you need to have much finer granularity on your location, well, then you probably want to use a Bluetooth solution, right? Some people might even say ultra wideband. In that case, you're going to have to put up an awful lot of Bluetooth beacons, right? But generally in something like a warehouse, you need much greater granularity on your location. So Bluetooth might be better for that.
Makes sense. So it sounds like there's a fairly natural trade-off between the range and the precision, I guess. Yeah.
So basically you want to choose the technology that gives you the location precision that you're looking for, right? And in this case, Bluetooth is good for much finer precision.
Cool. Okay, so I think this was covered in a little bit earlier, but I think it's good to review here as well. Is the Pepwave LoRaWAN Flex Module a base station and or a gateway in the architecture shown?
So the Peplink Balance 20X with the Flex module would be the quote base station / gateway.
Okay, just kind of combining that radio and that
Right.
upstream.
So you'll have a sensor, it'll talk directly to the Balance 20X, and then that will go directly to the cloud wherever you're running your network server.
Okay. Can anyone connect to your LoRaWAN gateway? I think this stems back to that public-private mode that we saw in the demo setup.
Yeah, so the whole concept of LoRaWAN gateways, believe it or not, came from IBM. And they kind of took what we call a Highlander approach. There can be only one, right? And they envisioned that every antenna of every LoRa gateway would be like one virtual antenna worldwide. Very IBM kind of idea, right? But that's the way it kind of works. LoRa gateways will receive packets from LoRa devices, and then the LoRaWAN protocol will determine whether that is forwarded. And because we do support roaming in LoRaWAN, right? So the whole idea of a neutral host is fully supported. So it will either forward a packet or not, depending upon how you want to dispose of those things. So the answer is kind of yes and no, but most LoRa gateways will receive all LoRa traffic.
Is there a LoRaWAN gateway device that I can plug into a balanced 310X? There's no Peplink provided LoRaWAN solution for the 310X right now. It's that balanced 20X is the current model in the lineup that supports that.
I know the next question is going to be the outdoor one. Here's kind of an example of what the outdoor will look like. This will probably be the next LoRaWAN gateway to come out. So it is IP67 rated, and it's an all enclosure to it. I'm not sure if we have a data sheet yet for it, but yes, there is a device coming for this. And then on the BR1 mini side, they're also looking at a smaller version. It's not going to be more of a BR1 mini, might be a little bit bigger than that. Might be a little bit different form factor, more around that UBR LTE, so kind of like a little bit bigger form factor. But yes, there are multiple devices that Peplink is looking at on for the LoRa. It's just the fastest to deployment was the balanced 20X with the Flex module, and then they'll launch more as we go.
I think we basically just knocked off 2 questions there.
Yep. I'm not sure on the ETA for the outdoor one. I would think in the next quarter,
We've got
depending on
about
certifications.
3 or 4 minutes left here, so. See a lot of questions just about recommendations for third-party servers to use. I don't know if I don't know if you have recommendations or just more or less a list of
I
popular
do.
platforms.
I absolutely, we work with all of them. And so you will be providing our email addresses, right? As part of this. I'm happy if you want to email me. I am happy to talk and give you recommendations on that. There are some really good ones out there, and it depends on, where you're going to put your network, right? Different parts of the world, what you're going to be doing. So there are quite a number of them, and we'd be happy to recommend the right ones for you.
I see a question on how much additional WAN data volume is generated between the gateway and the network server. I know the answer is not a lot, but that's not a specific or precise answer.
So, there's the answer that applies today. And then in the Alliance, we're actually working on the network server to gateway interface specification. And so today there's different pieces of software. I think you saw on the demo that Mike showed you, they have a thing called the UDP packet forwarder. That's the original LoRa, just moving packets back and forth kind of gateway software. And then there was this other one you might have seen that said Basics Station. That's a little more advanced, that incorporates some more kind of device management level sorts of capabilities. Well, the LoRa Alliance has never defined that specifically. And so we will be releasing a network server to gateway interface specification. And that's going to be probably about the end of the year. And we will also be releasing from the certification group certification test suites, so you can certify that your gateway follows that spec. So in the future, you're going to have a little bit different than what you have today. But as Travis said, overall, the additional data from the gateway that's generated by the gateway or sent just to the gateway is relatively small. It's mostly metadata about gateway's configuration, operation capabilities, and so forth, and state. Probably a few kbytes that's sent, every hour, something like that. It's not a lot.
All right, well, I think that wraps us up just perfectly here. I know there's a couple more questions out there, but feel free to reach out. We will continue this discussion. And really, that's the whole point of this webinar, is to get the discussion started. Any folks that are interested in deploying this technology, we've got devices and we've got experts here that know how to do this. So definitely reach out, and thank you so much for joining us, everyone. Thank you, Dave. Thank you, Mike. Much appreciated to have your expertise on this, and looking forward to see what people can do with this.
Yeah, thanks for having us.
Yeah, thanks, everybody.
All right, take care, folks. Goodbye.
Bye-bye.
See you.